Good morning. I am V.Nishadevi, Assistant Professor in Department of CSE. Today I am going to talk about the topic name is Uninformed Search Algorithm. It is the one of the topic for artificial intelligence and machine learning. Uninformed search algorithm means it's a general purpose search algorithm which operates in brute force way. This algorithm doesn't have additional information about the search space. It only the information have how to traverse or visit the nodes in the tree. So it's called blind search algorithm. This search algorithm produces the search tree without using any domain knowledge. This uninformed search algorithm having various types. That's called breadth first search, depth first search, depth limiter search, iterative deepening depth first search, uniform cost search, bidirectional search. So here we go for the first type, breadth first search. Breadth first search is the most common search strategies for traversing a tree or graph. This algorithm searches breadth-wise in a tree or graph. So it's called breadth first search. This algorithm starts searching from root node to successor node breadth-wise manner. It's example of a general graph search algorithm implemented using FIFO queue data structure. What is called FIFO? First in, first out. In a queue, we have to enter the first and first out. So that's called the queue data structure. Here the example of breadth first search. Here we have different types of edges or node. It's called the breadth first search tree. So first S is source node, K is successor node. In this root node to successor node, we have to traverse each node in breadth-wise manner. Okay. In level 0 source node and level 1 A and B node. So source node traverse each node A and B for breadth-wise, and level 2 nodes are C, D, G, H. So that in breadth-wise manner we have to visit C, D, G, H, and then level 3 in breadth-wise manner we have to visit E, F, I. So that level 4 in breadth-wise manner we have to visit successor node of K. So source to destination we have to search the node or tree in breadth-wise manner. That's called the breadth first search. Okay. So here the example of breadth first search tree. So how to it work in audit? So rule 1, visit the starting vertex and mark its visited, display it. Okay. And then second rule is, if currently working vertex has adjacent unvisited vertex means have to visit the adjacent unvisited vert and mark it is visited vertex. So insert it queue. After visit the node, it will be entered into the queue. Okay, so display it. So else update the pointer to the first element of queue. Okay, so after remove the first element from queue, it's called dequeue. So until repeat the rule 2 until queue is empty. It's called the breadth first search manner. Okay. So here the performance measure of BFS. BFS means breadth first search tree. Okay. So what is the performance measures? Completeness, optimality, space complexity, time complexity. So completeness means if it is the complete strategy as it definitely finds the goal state. S means completeness is S. So optimality, it gives an optimal solution if the cost of each node is same. Okay. So space complexity, the space complexity of BFS is O of B power D. What is called B? B is the branching factor, D is the depth or level of the tree. Okay. In the time complexity, BFS consumes much time to reach the goal node for large instance. So that memory space it will be occupied large. In this drawback we have to overcome, we introduce the depth first search. So next search tree is depth first search. Depth first search is the recursive algorithm for traversing a tree or graph data structure. It's called depth first search because it starts from root node to successor node in depth wise manner. It uses the stack data structure for its implementation. So similar to the BFS algorithm. Okay. So here the example of depth first search. Source node to destination, it will be traverse the each node in depth-wise manner. Level 0, level 1, level 2, level 3. So when it successor node revisit, after it this tree is terminated. Okay, so that's called the depth first search. Here the example of depth first search algorithm. So rule 1, rule 2. Rule 1, put the starting vertex into the stack, mark it is visited and display it. After rule 2, if stack is top, the adjacent unvisited vertex, visit the adjacent unvisited vertex and mark it is visited and enter into the stack. Okay, so else pop top element of stack. So here repeat a rule 2 until stack is empty. So here the example of DFS. And next, performance measure of DFS. So completeness, optimality, space complexity and time complexity of DFS is, completeness is not guaranteed to reach the goal state. No. So DFS does not guarantee to reach the goal state. So no. So optimality does not have an optimal solution as it expands the nodes of one direction deeply. So space complexity, O of BM, B for branching factor, so M for maximum length of the path. Okay, so in this time complexity, DFS has O of B of M time complexity. So in this next, so here the drawback for DFS is deeply depth will be drawback for the DFS. So it will be overcome about the problem. Depth limiter search algorithm. A depth limiter search algorithm is similar to depth first search with a predetermined limit. So depth limiter search can solve the drawback of infinite path in the depth first search. So it will be overcome about the predetermined limit. Okay, wow. Depth limiter search can be terminated with two conditions of failure: standard failure value, cutoff failure value. Standard failure value, it indicates that problem does not have any solution. Cutoff failure problem, it defines no solution for the problem within a given depth limit. So here the example of depth limiter search. Source to destination, it will be traverse the each node. When its limit reach, it terminate the tree. That's called the depth limiter search. Okay. So the performance measure of depth limiter search is completeness, optimality, space complexity, time complexity. So what is called completeness? Depth limiter search does not guarantee to reach the goal node. It does not optimality. It does not give an optimal solution. It expands the nodes till the depth limit. So space complexity. So O of BL. So length of branching factor. It's called the space complexity. And time complexity is branching factor, O of branching factor about the length. Okay. So next, uniform cost search algorithm. Uniform cost search algorithm is the searching algorithm used for traversing a weighted tree or graph. This algorithm comes into different cost is available for each edge. So the primary goal of the uniform cost search is to find the path of the lowest cumulative cost. So lowest cumulative cost, it will be uniform cost search expands the according to that path. Okay, this implemented by the priority queue, given the maximum priority to the lowest cumulative cost. So here the example of uniform cost search. Here the lowest cumulative cost, it will be visited to source to destination. Okay. So here the performance of uniform cost is, completeness is guaranteed to reach the goals. Optimality is gives the optimal path cost solution for the search. Space time complexity is worst space of the time complexity. So O of B power 1 plus C into divided by queries. So this is the uniformed cost search. So lowest cumulative search path is space time complexity is worst space time complexity of uniform cost search. So next is iterative deepening depth first search. Iterative deepening depth first search algorithm is combination of DFS and BFS algorithm. This search algorithm find out the best depth limit path, does it by gradually increasing the limit until their goal is found. So when its time depth limit is reached, it gradually increasing the depth, it called the iterative deepening depth first search. So here the example of iterative deepening depth first search. When it goal node is visited, time limit is visited, then it gradually increasing the depth first search, so that it called iterative deepening depth first search. Okay, so next one is performance measures of iterative deepening search. So completeness, iterative deepening search may or may not reach the goal state. Optimality, it does not give an optimal solution always. Space complexity, it has the same space complexity BFS, that is O of B power D, and time complexity also same of O of D, depth. Okay, so next one is bidirectional search algorithm. So bidirectional search algorithm runs two simultaneously searches, one form initial state called forward search and other form goal node called backward search. To find the goal node, bidirectional search replaces the one single search graph with two small subgraphs with one start go for goal vertex. This search stops the two graphs insertion each other, so that bidirectional search can use the search techniques such as BFS, DFS and DLS. Okay, so here the example of bidirectional search. Root node to visit the goal node, intersection node is 9. So here the bidirectional search example. So performance measures of bidirectional search is complete. Bidirectional search is complete, so it's called as optimal. It gives an optimal solution. Time and space complexity bidirectional search has O of B power D divided by 2. B for branching factor and D for depth. Okay, so here the comparison chart for all the types of uninformed search strategies. Here the B is branching factor, D is solution depth, L is depth limit and A is complete if B is definite, B complete if step cost of E is positive. So M equal to max tree depth and C cost of optimal.